This is Module 11, the Integrated Review. Here we're going to summarize all of the factoring techniques we talked about earlier in Module 11 and apply them to a few problems as you would, say, on an exam. Factoring summary. Your first step is to always factor out a greatest common factor if possible. Second step, look at the number of terms in the polynomial you're trying to factor. If there are 2 terms, try the difference of squares. If there are 3 terms, look and see if it's one of the easier trinomials, x squared plus bx plus c, where you find factors of c that add to give you b, and then simply put those factors in your binomial groups. Or if it's one of the more complicated trinomials, ax squared plus bx plus c, you can use the grouping method that we talked about. Remember that the easier trinomials can all be factored using the ax squared plus bx plus c grouping method as well. If you have 4 or more terms, then try factoring by grouping. Always make sure in step 3 that you factor completely. Just don't do one step. If there's multiple factoring steps you can do, factor until there's no more factoring steps to complete. And you can check your answer using the FOIL method or distributive property or whatever seems appropriate for that particular factored problem. Note that in this section we did not cover factoring the sums or differences of cubes. So if you happen to be looking through your book and you see the book talking about factoring sums and differences of cubes, you are not responsible for that. All right, so let's look at these general examples. 2xy squared minus 50x. Your first step, always look for a greatest common factor and factor it out first if possible. Notice that this particular problem has a common factor of 2 and also a common factor of x we can pull out. So if you take 2x out of 2xy squared, you're left with y squared in your group. Minus 50 divided by 2 is minus 25, and we did take the x out. Now look in your group and see if there's something further you can do. There are 2 terms in that group, followed by subtraction. 2 terms with subtraction may be difference of 2 squares, and in this case it is. Note that the y squared minus 25 will factor out to give you y plus 5, y minus 5, and then don't forget the greatest common factor that you factored out in the first step. That is your final answer. All right, now let's look at that and check that answer. Since that's a little more complicated, notice that we do have a piece that looks like your basic binomial times binomial. So you could use FOIL method there, or you could use the area model or distributive property or whatever you like best. Now we also have a 2x out in front here, and a lot of times students will do that first, thinking that it's distributive property and that's what they're most comfortable with. The thing I want you to know is if you choose to do distributive property first, that 2x only distributes to one of the groups, not both of the groups. Okay? And a simple example to demonstrate that is this. If you had 2 times, let's use numbers. Let's say 2 times 3 times 5. You agree with me that that 2 does not multiply to both the 3 and the 5. It just multiplies to the next multiplication term, orders of operation. You'd take 2 times 3 is 6, and then that product would multiply to the 5 to give you a final answer of 30. Although this looks similar, it's really exactly the same. Okay, you have one thing being multiplied to a second thing being multiplied to a third thing. One thing multiplied to a second thing multiplied to a third thing. So if you choose to do distributive property first, that 2x would only distribute to the next factor, and then whatever you got after you distributed it to that first group, you would then multiply that group to your last group, y minus 5. Since most students find that fairly confusing, what we're going to do is we're going to go ahead and do the FOIL step first, see what we get when we get y plus 5, y minus 5, and then multiply the 2x to that. All right, so I'm going to do this step first. Remember, commutative property of multiplication says you can multiply in any order you want. So y plus 5 quantity times quantity y minus 5, if you like the FOIL method, would give you first 2 would be y times y, or y squared. Outer 2 would be y times minus 5, which is minus 5y. Inner product is plus 5 times y, which is plus 5y. And last 2 would be plus 5 times minus 5, or minus 25. Notice that the minus 5y and the plus 5y cancel out. That leaves you with y squared minus 25. And then that quantity will now be multiplied to that 2x, which I left for my last step. Now this is straightforward. This would distribute, and it only distributes to that single group. If you distribute that, 2x times y squared is 2xy squared, minus 2 times 25 is 50, and that x tacks on to the end of it. That should be your original problem, and it is, so that checks out fine. All right, let's look at 3y squared minus 15y minus 252. First step, always ask yourself, is there a greatest common factor? And although 252 is a pretty big number, if you get out your calculator, you will see that 3 does divide evenly into all 3 of those numbers. So if you pull your 3 out, you're left with y squared minus 5y minus 252 divided by 3 is 84. Now your next step is looking at the group that's left after you take out the greatest common factor. Will that trinomial factor further? And inside the group, notice that it's one of your simpler trinomials. It's an x squared plus bx plus c trinomial. There's an understood 1 there. So what we need is simply factors of negative 84 that add to give us our b term, which is negative 5. And if we can find those factors, those are just the last factors in our group, because this is one of the simpler trinomials. And it turns out that negative 84 can be found by multiplying 7 times negative 12. But when you add 7 and negative 12, you do get negative 5. So those are your factors that are going in the last position in each group, because this is one of the simpler trinomials. So we can simply put in our plus 7 and our minus 12, and then our y's go in the first position. And then don't forget the 3 that you factored out at the beginning. Our final completely factored problem is 3 times the quantity y plus 7 times the quantity y minus 12. All right, let's look at this problem. A cubed minus ab squared plus a squared b minus b cubed. Your first step is there a greatest common factor that you could factor out of all 4 terms? And the answer is no. There is not one factor that is present in all 4 terms. So your next step is look at the number of terms. There's 4. 4 almost certainly means it's a factoring by grouping problem if there's not a common factor. So group in pairs, factor out of each pair. Out of that first group, we can pull out 1a, which leaves us with a squared minus b squared. Out of that second group, we can pull out a single b, which leaves us with a squared minus b squared. Now our groups match, so we can pull that group out, a squared minus b squared, and multiply it to whatever's left, which is a plus b. Now at this point, you might think that you're done. However, notice in that first group, a squared minus b squared, that is the difference of 2 squares. A squared is a times a, b squared is b times b, and it's separated by subtraction. So that first group will factor even further. The a's go in the first position, the b's go in the second position. 1 is addition, and 1 is subtraction. And then that third group tacks on a plus b to give us our final factored answer. Also note that since 2 of those groups match, a plus b and a plus b, you could, if you wanted to, write that as group squared, a plus b squared, because it appears twice, times a minus b. Both of those boxed answers indicate the same thing, just slightly different form. Okay, so let's look at the next example. 10y cubed minus 23y squared plus 12y. First step, always look for a greatest common factor. In this case, the greatest common factor is just a variable term. We're going to have to pull out a y. That leaves us with 10y squared minus 23y plus 12. Now, can we factor this trinomial further? This is one of those more complicated trinomials. This is the ax squared plus bx plus c form. So using the factoring by grouping method that we talked about, where we take a times c, that would be positive 10 times positive 12, which gives us a positive 120. We want factors of that that will add to give us our middle term, which is negative 23. So we want to break down positive 120 to get factors that will add to give us a negative 23. There's a lot of different possibilities for 120, and your calculator can certainly help you with that. I believe you'll find that if you take negative 15 times negative 8, negative 15 times negative 8 is a positive 120, and negative 15 plus negative 8 is negative 23. Now remember, this method for the more complicated trinomials then takes those factors and rewrites the middle term. Now I'm just looking at the group, and then I'll deal with the greatest common factor in a minute. So you're going to rewrite the problem, 10y squared minus 15y minus 8y, or plus a negative y is fine, plus 12. Then we're going to group in pairs. Remember that if there's subtraction, you've got to include that subtraction in your group. Factor each group. So out of this first group, I can pull a 5 and a y out, which leaves me with 2y minus 3. Out of my second group, because that leading term is negative, I know I'm going to pull out a negative something. Here I can pull out a negative 4, which leaves me with 2y, and 12 divided by negative 4 is negative 3. So 2y minus 3 as well. My groups match, and so I've got my group, 2y minus 3, times my group of what's left, 5y minus 4, and then don't forget that y that you factored out at the very beginning to give you your final answer of y times the quantity 2y minus 3 times the quantity 5y minus 4. And this is the end of Module 11, the integrated review material. This is also the last video for Module 11. You now should complete the homework for the integrated review found in MyMathLab. When you have successfully completed the above homework, review all the material for Module 11 and complete the Module 11 exam found in MyMathLab. After successfully completing the Module 11 exam, review all of the material from Modules 6 through 11 and complete the final exam found in MyMathLab.